Welcome to MouShauk. How are you, friends? Today we will be discussing the respiratory system part 4, that is some of the remaining part of this chapter that is left, some experiments on the respiration, and this is inspired and expired air. So before I start, I will request you to please to subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. And we will also start with this discussion with the short meditation as earlier. So we will let us start with the meditation, short meditation. So let's concentrate on the point of light. Think that light is part of you, and you're feeling relaxed, very free of any tension, feeling that everything is very new. Your body is new. The circumstance become real. Whenever you are studying, the clarity in your mind, the capacity of the very easily in your thinking, the better situation, the empathy, the thinking, in our last video, we have studied about the inspired air, expired air we were studying. Okay. So, I mean, we were studying with the capacity of the lungs. Okay, how the lungs can take what is the volume, tidal volume, inspired reserve volume, then expiratory, inspiratory volume. Okay, inspiratory capacity, expiratory reserve capacity, then residual capacity, then total lung capacity. These all we have studied. Now we will be today starting with inspired and expired air. Okay. So what is inspired? What is expired air? Inspired air is that air which we take inside the body through our nostrils. During inhalation, when we inhale air, so when we are inhaling through our nostrils, that is taking in the air in through our nostrils, that time the air the air which is getting inside, that is the inspired air. And when we are breathing out, that time the air which is coming out from our lungs, that is known as exhaled air or expired air. Okay, exhalation. Now, the inspired air which we are taking inside, that has more oxygen, that is rich in oxygen, okay? And the expired air which is coming out from our lungs, that has more of carbon dioxide. So that is rich in carbon dioxide. The temperature of the inspired air is variable, but the temperature which the air, when it is coming out of our body, that is same, okay, as that of the body temperature, because it's coming out of the body. So that is equal to around 37 degrees centigrade, okay. Inspired air contains less amount of water vapor, whereas expired air contains more of water vapor. Then inspired air, variable quantity of dust particles are also present, okay, inside the inspired air. But in expired air, dust particles, if present, they are very little in quantity. Whereas inspired air, lots of bacteria and molecules are present. Okay, microbes are present inside the this inspired air because it's coming out from the outside. But expired air, that may contain some bacteria because it's inside the body. Okay? Now, when we are rising up, okay, when we are going high up certain mountains or like that, altitude is high. Okay, that time what happens? The pressure, air pressure decreases. Okay, the air which we are breathing in, that pressure decreases. So therefore, when the air pressure is decreasing with the altitude, then the oxygen content will also gradually decrease. Okay. At about 4,500 meters above sea level, when we have traveled, suppose we have traveled around 4,500 meters above the sea level, that time what happens? The person may suffer from air sickness. Due to why? Because due to there is lack of oxygen. I told you the air pressure decreases with the increase in altitude, and when the air pressure decreases, the oxygen content of the air that also decreases. So at high altitude around 4,500 meters, that time a person can feel air sick. Why? Due to the lack of oxygen, which may lead to dizziness. Okay. It may lead to dizziness, unsteady vision, loss of hearing, then loss or lack of muscular coordination. Okay, there can be dizziness, there can be unsteady vision, loss of hearing, lack of muscular coordination, and even there can be complete blackout. That is, the person can fall unconsciously. The person can become. So these two conditions may arise due to this poor oxygen content of the air. Due to the deficiency of oxygen, which is reaching the tissues, okay, uh, mainly, especially in a crowded room where there is poor ventilation. Okay, if a person is sitting in a crowded room with poor ventilation for long hours, a person or at a high altitudes where the oxygen content in the air is less, then a person the oxygen due to this deficiency of oxygen, the oxygen reaching in the tissues that also decreases. Okay, so this condition is called hypoxia. Okay, this condition is called hypoxia, when due to the deficiency of oxygen reaching the tissues, a person who is sitting in the crowded room with poor ventilation for long hours or at high altitude, oxygen in the air is low. Okay. So the oxygen air is low, that time the hypoxia can arise. Then asphyxiation, okay, this is the condition in which the blood becomes more venous. Okay, that is more of carbon dioxide. Okay, the venous blood contains more of carbon dioxide. So the accumulation of more of carbon dioxide in the blood takes place. Why? And oxygen supply is diminished. Okay, so this is also a poor condition of oxygen supply, oxygen content in the air. So this condition is also known as asphyxiation. So where there is more of carbon dioxide accumulation in the blood and oxygen supply is diminished. Okay, this may happen due to what? Strangulation, drowning, any obstruction in the respiratory tract. Okay, strangulation, that is if there is a if somebody strangs his or her neck, I mean throat. So that is, it can happen. There is oxygen content, supply content, oxygen supply gets diminished and accumulation of carbon dioxide. Then in the blood, then if a person is drowning, okay, there also one can have less oxygen supply and more of carbon dioxide accumulation in the blood. Any obstruction in the respiratory tract, okay, oxygen is not getting inside the respiratory tract properly, and carbon dioxide that comes gets accumulated in the blood. So this can lead to death if the cause is not taken care of quickly. Okay. This can be treated with artificial respiration. Any kind of artificial respiration, that is, if oxygen is supplied artificially, then this can be treated up. Then some experiments on breathing and respiration. First experiment to demonstrate that water is lost during breathing. Okay. So if we breathe gently on a cold surface, okay, a place if we take a piece of glass or slate and there we breathe on that surface, then we can see what happens. Droplets of water coming on the surface, appearing on the surface. That, I mean, this shows that the breathing which we are doing, okay, that is when we are expiring our air, exhalation of air, that time water is also lost. Okay? The presence of moisture in the expired air, that is, it proves. Then to demonstrate that carbon dioxide is given out in breathing. In this experiment, we take two flasks, okay, two bottles, okay, conical flask. With that, we attach some tubes in such this way where we can see that where we can see that there's two clips. Okay, two bottles are there. One is A and B. Okay, in both of them we have lime water. Okay, and from this side, you can see the arrow from this side towards the clip C. There's two clips, clip C and clip D. Okay, from this side, the air is getting inside. From the left hand side, the air is getting inside, and from the right hand side, the air is getting outside. Okay, and from the middle piece, from there we breathe in and breathe out. Okay, so what do we do? I'm sorry. Yes, when we are breathing in, this clip C is opened and clip D is closed. When we are breathing in, the lime water remains as it is. Okay. But when we are breathing out, we close the clip C and open the clip D, then we are breathing out. Then we are breathing out, that is expiring our air. That time we see that the lime water turns milky. So this shows the air which is getting inside the flask A, that contains less of carbon dioxide. Okay. And when we are expiring our air, into the flask B, the lime water turns milky. So that means that when we are expiring our air, that contains more of carbon dioxide, which turns the lime water milky. This is the property of lime water. When carbon dioxide is mixed with the lime water turns milky. So this is the property and this is the test for carbon dioxide. Okay. So when the lime water is turning milky fast, that means it has more of carbon dioxide. And when the lime water is turning very slow, milky, that means it has less of carbon dioxide. Okay. So inspired air has less amount of carbon dioxide than the expired, and expired air has more of carbon dioxide. So this shows that expired air contains more carbon dioxide than the inspired. Okay. Next, in the third demonstration, there is a diaphragm which helps. It means that the experiment shows the action of diaphragm during breathing. Okay. So we take two bottles with cork attached to it, and a tube is attached in both the flasks with two balloons inside the flask, and there is another rubber shaped balloon which is attached in both the flasks. Okay. Now, with both the bottles. Okay. Then in the first bottle A, what do? We pull the balloon from the rubber which is attached at the end of the bottle. We pull it. Okay. So what happens when we are pulling the rubber down? That makes the volume inside the bottle more. Okay. So at that time, the air will rush inside the bottle through the tube. That is, it will get inside the two balloons which are attached to the tube, and that those balloons will inflate. Okay. But in this, that is, air is gushing inside. And the second bottle, second experiment, what we do, we push the rubber inside. Okay. When we are pushing the rubber inside, bottom rubber inside, then we see that both the balloons which are attached to the tube that deflate, showing that the air will rush out of the tube. So this experiment proves the action of diaphragm in the breathing. It shows the action of diaphragm in the breathing. That is, when the diaphragm is, when we are breathing in, the diaphragm goes down, which increases the volume of our lungs, and the air will rush inside our lungs. Okay, and when the diaphragm goes up, okay, when it contracts, then what happens? Then it will push the lungs into the, it decreases the volume of the lungs, and that will make the air inside the lungs come out. Okay. Next is to measure the volume of the expired air. How do we measure the volume of the expired air? We take a big flask where two tubes are attached. One the air is blown inside the flask, okay, and it has water inside, okay, and through the other, the water will flow out of the bottle into a measuring cup. Okay. Now, the air is blown from our mouth. That is when we are expiring the air from the mouth into the bottle from the left-hand side. Now, the right-hand tube, after blowing the air inside the bottle, the air will go mix with the water, and the water from the bottle will come out of the tube and flow into the measuring cup. After this measuring cup has filled with the bottle, it has been filled with the bottle, water, that will give the volume of the air which is being breathed out. Okay. So this is how the volume of the expired air can be measured. Next is another experiment. It shows that oxygen is taken out during respiration. So we take two conical flasks, okay, close them with cork, rubber cork. We place two candles, one in each, with a rather hook. We put the candle slowly inside, burning candle. Okay? And we take one living cockroach, another dead cockroach. Keep the living cockroach in one flask, another in the A flask, and in B flask, we take a dead cockroach and keep it in the B flask. Okay. Now, we will watch the burning candle extinguishes fast in which flask. We'll see The flask B, where there is a dead cockroach, there the candle remains longer burning. But in the A flask, that extinguishes faster. Why? Because we have a live cockroach present in the first flask, A bottle. Okay. Now that live cockroach is also utilizing the oxygen, same oxygen which is present in that flask. And the burning candle uses the oxygen which is present in the flask. So both of them are using. So oxygen is being divided between the burning candle and the living cockroach. Okay. So it has been, so as long as the oxygen is there, the cockroach is also taking and the candle is also burning. But as soon as the oxygen is being utilized, the candle extinguishes. But in the B flask, B bottle, that dead cockroach is not able to utilize the oxygen. Only the burning candle. That candle is only utilizing the oxygen which is present in the flask. Only candle. Okay? So that is why it is utilizing the whole oxygen which is present in the flask, and that is why it can be burning. It can burn longer than the flask A, than the bottle A. So this shows that oxygen is taken in during respiration. Okay. So let us end here. Okay. This is the end of the chapter. We will discuss in the next video some question answers, important question answers on this chapter. Okay. So till then, go through these chapters, chapter videos. Okay. If you have any doubt, please do write in the comment box. Do share with your friends so that they can also be benefited from these videos. And do meditate before you start your day. And also, the links of this chapter, the videos of this chapter will be there in the description box. You can refer to them. Okay. So thank you for joining and have a good day.